Alright, so let's go over the homework. I had asked you to do 5 problems, so let's go ahead and do those. I'm going to copy and paste this to save us a little bit of time to go over things. Alright, so now let's take a look at the homework. So number 1, the problem said y is equal to 2 sine of x minus 45. So the amplitude is going to be 2. Period is going to be the normal divided by 1. And the phase shift is going to be 45 degrees to the right. So I'll make a table, or I'll just type this into my calculator. And I'm going to be typing in 2 times the sine of a minus 45, and let's start at negative 360. And my calculators tell me it's negative 1.4. So if the period's 360 degrees later it'll be that, and 360 degrees later it'll be that. Let's try negative 270. I'm getting 1.4. Interesting. My stuff's in the way here. So 360 degrees later. 360 degrees later. Okay, let's try negative 180. And I'm getting 1.4, interesting. And I think what's going to happen is the graph will negative 90. Let's just do one more here. Negative 90. Yeah, it's looking like negative 1.4. Okay. So it looks like we're 2 up to 2, and then 2 down to 2. 2 up to 2, 2 down to 2. I guessed that one a little bit here. Something like that. Alright, so that's how you draw the graph there. I know the amplitude was 2, so I had to go up there. Alright, so for the second one, y is equal to negative 2 cosine of 3 theta. The amplitude would be 2. I have to get up to 2 somehow. The period would be the normal, 360 divided by 3. So we're going to be repeating every 120. And the phase shift looks like 0. So I'm going to actually modify this a little bit here. I'm going to put 120 degrees in here because the period is going up by 120. So let's see here. I know 0. This would be 120. 120 later would be 240. 120 degrees later would be 360. 120 before is negative 120. And negative 240. And then negative 360. So let's draw this out here. When the period is like a wacky thing, like if it's not 0, 90, 180, 270, then maybe this would be a better approach to graph this. So negative 2 times the cosine of 3a. Start at 0 this time. We'll use the 120s. So negative 2 times the cosine of 3a. And use 0. And I'm getting negative 2. So 120 degrees later, it'll be the same thing. 120 degrees later, the same thing. 120 degrees later, same thing. 120 degrees in the other direction. Alright, so that's good. So, in between, I would imagine the graph has to hit 2. So the only way this will work is if the graph kind of goes up to 2 in the middle, then it goes back down, and then it goes back up, and it goes back down, it goes back up, it goes back down. So something like that is what it has to look like. Something like that. All right, now my graphs don't have to be perfect. I mean, if we wanted to be more exact, I mean, we could try 90 degrees. Let's see what that would do. 90 degrees, I'm getting 0, and that's kind of what I thought it would be. What about a 270? 270 is 0. So you could see it's almost like an art trying to figure this out, but it looks like every 120 degrees we're getting the same graph, and that's the whole point of a period, right? Every 120 degrees we are getting the same thing. Okay, we have a few more. And let's see here. For number 3, it says y is equal to 1/2 cosine of x minus pi over 2. Alright, so we know that really in degrees, I told you could do this in degrees. 1/2 cosine of theta minus 90 degrees. So this one's a little bit more straightforward. Amplitude's 1/2. Period is 360 divided by 1. And the phase shift is going to be 90 degrees to the right. So if we make a table, I'm going to type in the original. 1/2 cosine of theta minus 90 degrees, using our period to help us draw this. So 0.5 times the cosine of an variable a minus 90. If we plug in negative 360, I'm getting 0. The period's 360, so I'm going to go up by 360 just like that. If we use negative 270, I'm getting 1/2. So it has to be between these lines, right? If the amplitude is 1/2. So I'm getting 1/2. So 180 degrees later, it's 1/2. Kind of get the idea of what this is going to look like. Oops. Let's just kind of fill in the dots here. Something like that. Okay. And you could always pick more points. If you're not really sure where that came from, keep going. I mean, plot negative 180, you'll see that it's 0. Plot negative 90, 0. You can pick as many points as you want. Number 4 is similar. It says y is equal to the sine of x over 2 plus 90. So we're going to have to take out that 1/2 to figure out the components. 90 divided by 1/2 is 180. So the amplitude of regular sine is 1. The period would be 360 divided by 1/2. Oops. And the phase shift is 180 degrees to the left. Phase shift doesn't really matter most of the time when you're graphing. So I'm going to make a table here. And we'll graph sine of a divided by 2 plus 90. Start with negative 360, then we'll do negative 270, negative 180, and hopefully we'll get the hang of things. I'll graph it in red because my writing is in the way here. So I'm going to type in the sine mem variable a divided by 2 plus 90. And negative 360, if we store that, we're getting negative 1. Period 720, so 720, it's also going to be negative 1. Okay, negative 270, we're getting negative 0.7, negative 180, we're getting 0. Looks like the amplitude has to be 1, right? So we're going up to this line and down to this line. So we kind of see where this is going. It's curving up. It's going to be probably about 0.7 there. Just double check. That's exactly what it is. And then it's going to start coming back down. Alright, so it's like a super stretched out wave. Alright, last one. One more. I love this stuff. Actually, not really. You'll see, it's coming up. Section 7.2 is awesome. That's my favorite section. So y is equal to sine of x plus cosine of x. We had a similar one to this in the notes. And we said this is a wave, this is a wave. You combine two waves, you probably get another wave, right? So let's see what this looks like. We'll have to use our calculator. And let's see what happens. So I'm going to type in sine mem variable a plus cosine mem variable a. Negative 360. Store it. My calculator is telling me that this would be 1. Negative 270. Store it. I'm seeing 1. Negative 180. Store it. Negative 1. Okay, so I'm kind of getting the idea it's going to look like this, but I'm not 100% sure, so let's try negative 90. Eventually you should see a pattern, right? And then 0, we're back at 1. Alright, so that's the game we're going to play here. The tricky part is what's going on in the middle. So let's see. I'll try negative 45. I'll store that. And I'm getting 0. That's interesting. Oh, negative 45. I think I stored positive 45. So negative 45, store it. I'm getting 0. Okay, that makes a little bit more sense. At positive 45, it's probably going to be bigger than 1. Let's see here. 45, store it. I'm getting 1.4. Okay. So it looks like in the middle it's going up to 1.4. Then it goes down to negative 1.4. Then it goes up, positive 1.4, and comes back down. So that's what the graph looks like. All right, so stay tuned for today's lesson.